Hello viewers, welcome to BikeGremlin video YouTube channel. In this video I will explain the procedure of removing and mounting threaded bottom brackets and cranks. In this particular video it's a square taper crank, but similar procedure goes for octalink cranks as well. First I will explain something about the needed tools before we get on to the procedure. For removing the cranks, first thing we need is to remove the bolt that puts them onto the spindle or bottom bracket axle. It's usually either 14 or 15 millimeter six-sided nut, or like in this case, an 8 millimeter Allen wrench is needed. So that is the first thing that needs to be prepared and used to remove them. After removing these bolts, the next thing that is needed will be, here I'm showing what the tools look like. This is 14 millimeter six-sided uh, for ratchet mechanism adapter. Sorry about my imperfect English. And here the next thing that we will use after removing those bolts will be a crank puller, and the way it works is demonstrated here in this video. The outer side of it has threads that are screwed into the, here I'm showing where they are screwed in, and then when the inner side is threaded in, it pulls the cranks outwards by pushing against the axle, the bottom bracket axle. And for operation of this tool here, 17 millimeter spanner is used, or sometimes some tools require 16 millimeter or similar. And here I'm explaining that in order to avoid damage to this interface and the threads of the bolt that puts the cranks onto the axle, I sometimes put a blank smaller size bolt inside so that the crank puller leans against it instead of leaning against the axle directly. Good quality crank pullers don't require the use of this adapter. Okay, now I'm starting with the procedure. I forgot to mention that I have also recommended and explained the use of lubricant oil for this procedure, as will be shown afterwards. It will show in the video. I will talk about it when the time comes. For beginning, I'm unscrewing both pedal locks, pedal nuts that put the cranks onto the axle. As you can see in the video, both nuts have some anti-seize paste mounted on them, put on them. That was done when the cranks were first installed several years ago. This bicycle had seen a lot of all season riding and many miles, and now was the time for a complete overhaul and changing all the worn parts. Also some painting of the frame was also done in the meantime. Some pictures of that are shown on my Facebook page. I might include a link in the comment section. Here, what I'm doing with the oil is now lubricating the threads where the crank puller will be threaded into, to make sure it is all clean, and because it's a very fine pitch thread, it's important to make sure it's clean and lubricated so that the crank puller doesn't damage the threads, because that will make afterwards a removal for the second time when it's needed very difficult. Here I'm inserting a small bolt inside. This is just a precaution. It's probably not necessary with good quality crank pullers. I'm just showing it here as an option. I'm now turning the tool anti-clockwise until I hear and feel a click, which means that the threads have aligned against each other, and then I can turn it clockwise to screw it in. I will also include a link in this video comment section about threads, the left and right-handed thread, just in case someone is not familiar with that. it won't hurt to give that info. Okay, I had now tightened it completely against the outer part was now completely tightened, and after that I'm now tightening the inner part in order to push the crank away from the axle. Sorry. It sometimes requires a bit of force at the beginning, and you can feel once it is detached it will go easily. Before removing the crank completely, I like to use the axle as an anchor so I can easily unscrew the tool. Now I've loosened it. Okay, I can now remove the crank and then remove the tool completely, the crank puller. There you can see the bolt that was left inside. Here it also shows some anti-seize, that paste that was in this particular case it was copper paste or copper grease. I'm now repeating the same procedure on the left crank arm. It's completely the same. All the threads are the same. For that matter, exactly, just copy paste. After this was done, it's time to go to the second case, to removing the bottom bracket. But before that, I'm explaining here the procedure of mounting the cranks. For that, it is very important to lubricate the axle. Especially, best thing is to use some anti-seize paste or at least some grease. It's best not to mount dryly, in spite of what some manufacturers recommend. Then it is important to lubricate the bolt that tightens the crank against the axle. Then mount the cranks watching so they are both 180 degrees from each other turning, and then tighten each crank as with a lot of force. I think it's some 30 Newton meters. I must check. I will give that info in the comment section, or you can ask if it's needed, but most manufacturers give that info. If using any mounting paste or grease, recommended dry mounting in Newton meters force should be decreased by 20% in order not to overdo it, since lubricants allow for the same pressure to be achieved with using less tightening force. Again, sorry for the Tarzan English. I hope it's clear what I mean to say. So that is the procedure for mounting the cranks. I will now remove and show how the bottom bracket is removed, and then explain the procedure for mounting the bottom bracket. Now, when removing bottom bracket, there are two standards. All the bottom brackets that are threaded have the left-hand one, left-sided cup. Left-sided cup of the bottom bracket is always using right-handed thread. Okay, I got it clear with no mistakes. I will, like I said, also include some links. The right-sided cup sometimes has left, sometimes right-handed thread, depending whether it is Italian or British standard or some other. So a safe bet is to remove the left-sided cup first, and then you can measure it and see in my chart about bottom bracket standards, depending on its diameter and measuring that, you can tell which standard it is. Is it British, Italian, or some third, so that you can know in which direction to turn the right-sided one in order to loosen it, so you don't make a mistake of further tightening it or damaging the interface by too much force using. In that case, it will be even harder to remove afterwards. So first I'm trying to remove the left-handed cup. It is, like I said, always right-handed thread, so I'm now turning it anti-clockwise in order to remove it. But before I do that, since it will require a lot of force, I'm making sure that the frame is securely tightened and not damaged. So I will lift it up and tighten it closer to the bottom bracket, especially if it's an aluminium frame. This one is a very sturdy and heavy steel frame, so it's bulletproof. but for more lighter racing frames, it's better to play safe and tighten it closer to the bottom bracket. And here I'm unscrewing now. It's going easily. I have used this old bolt that is used for mounting cranks in order to hold the tool in place so it doesn't slip and damage the interface. And I will also have to use the crank to mount it, just to use it as a leverage, because it won't now be turned unscrewed by hand. I have just unscrewed the cup by half a turn to make it go easily. After that, I'm removing this bolt, since it would prevent me from unscrewing further, so I can easily unscrew the cup. If you're working with carbon frames, if there are any with threaded bottom brackets, it's best to hold the frame on its wheels on the ground and not try to hold the tubing in some stand like this, because it can get damaged when a lot of force is used on the bottom bracket while unscrewing it. That's an important thing to pay attention to and to note. Same goes for very light aluminum and steel racing frames. Safe bet is on its wheels, or at least not mounted as high as it is in this video, but closer to the bottom bracket when mounting it on a mount, on a working stand. Here I know that the bottom bracket is an English British standard, so that the right side cup has a left-handed thread, but otherwise I would have measured it and made sure to know what I'm dealing with. So in this case I will have to turn the tool clockwise in order to unscrew the right-sided cup. I will again use a bolt to hold my tool in place, and so it doesn't slip, and then I will try to unscrew it. In this part I'm explaining in Serbian the problems of Italian and similar threaded bottom bracket standards that use a right-handed thread on the right side cup. The problem with that is that because of the bearing movement and rotation of the cranks, the cup has a tendency to unscrew, while the British standard has a tendency to further tighten both the left and the right-sided cup, which is a better option. For Italian and similar standards, it's needed to put a lot more force when tightening to make sure it doesn't become loose over time in time, and it is also sometimes necessary even to use some thread locker for that, which is a poor design and a jewel of Italian engineering. Yes. Now I've set up the whole thing, and I'm starting to try to unscrew it. Here I'm using a very short lever, and it's not working. While most videos often make things look like they are too easy, here it's been really hard. Now I'm trying to put some precautions like I had explained. The left-handed one went out easily, and this one is stubborn, so I will first mount it closer to the bottom bracket, keep it all tight, then try with a lot more force, and as you will later see, it was to no avail. And this was very good for demonstration. I hadn't planned it to go like this, but it had turned out perfect in my opinion to show what you can run into. Here we have a bottom bracket cup that is stuck, and I know in this particular case that some anti-seize had been used, so it didn't galvanically weld, it just needed a lot of force. But here I will show a procedure in case it is galvanically welded. This frame was to be repainted again, so this will damage paint, but try to use some perhaps more sophisticated method of heating the frame's shell, and trying not to heat the cup itself, so that it expands and creates some room for the cup to be unscrewed. This is especially important with aluminium frames where there can be some galvanic welding. Of course, try not to heat aluminium frames too much because it will soften the material and it can be problematic. So best use some sort of hair dryer or something like that so you don't overdo the temperature. In this particular case, all that was needed was a longer lever, and I knew there was no galvanic welding, but I here showed a procedure of trying to make the connection unstuck by using a hammer. Safer bet would have been to hold one hammer in place and hit it with the other so I don't miss and hit another part of the frame instead of just hitting the bottom bracket. Now I'm using a longer lever, a longer bar, and it's got unscrewed, and that was the procedure for removing. It will now go easily. I unscrewed the bolt that I used to hold the tool in place, so I can now easily unscrew the bottom bracket. It won't go by hand from the start, but after a few turns it went smoothly. When I finish this, I will explain the procedure of replacing. We can imagine that I'm putting a new bottom bracket inside. So the first thing is to make sure that all the threads of the frame's shell of bottom bracket and the bottom bracket itself are clean and lubricated with some. It's best to use anti-seize, like I said, not just ordinary grease, because anti-seize will do what it says, prevent it from seizing in time, while grease is relatively temporary. After a year you cannot count on it to still serve that purpose. Now the way I do it is to first put the left cup in just by a couple of turns to serve as a guide while before I put the right-sided cup inside. And with these cartridge bottom brackets, it's always a one unit. There's no cup and cones and no loose axle, so it's a bit easier. But the system and the procedure is the same for cup and cone ones. Here I'm now starting to thread it in a clockwise, which is way to unscrew it before I hear a click, so I know that the threads are aligned, and then I'm turning it anti-clockwise since it's a left-handed thread in order to screw it in. Then I would screw it in all the way with the recommended force tightening force, and only then would I go back to the left-sided cup and screw that one in all the way. This is the whole explanation. Thank you for watching.